After implement your, let's say, fast API and made this Dockerization, and you have to ask yourself some questions. Is your fast API apps really ready for production? How many users can it handle before it crash? And are, let's see, your endpoints optimized? And in today's video, we will go, let's see, to do some, it's real test. And we are loading test our fast API app running inside a Docker using the power, let's see, of Locust. I have also mentioned it last time, this one here. And it's a modern, scalable Python-based performance testing tool. It's really ready to simulate real users and also expose real bottleneck in your end fast API. So let's see, we have already our fast API. We have already an image of our fast API. Now let's try to run our fast API. Let's just open a terminal. Before this, let's go to the Locust. So we have to also to install this. Uh, before you need before you run this, you have to add, let's say, to install the Locust, which is, if you have, let's say, cloning my repo, it's already installed. So it should be here, Locust. Yeah. So if you just cloning this, it should work in your side. And by end of this video, you will know how to set up your Locust for Dockerizing fast API, simulate maybe thousands of users hitting your endpoints. But I will try with 10, let's say 10 endpoints, maybe 100, because my notebook, it's not that powerful, I will say. And I have no GPU here. Everything is running on CPU. And also read live metrics and discover performance issues, both maybe your backend reliability with real data. So as you can see here, this is our locust file. And in this case, I will try to call this. This is a task test interference. And here I have, because I'm using images, I will just add generate random image here and save it as image and send now the buffer with the client. You can see here, send post predict and the file and also the parameters. Now we will see how to do so. So let's see, I have this image here. Now I need to run the Docker image. So then we need to run the locust file. So you can just maybe, I think it's fine here, like, so you need even without this, I think, but we need to copy this for the next time. Let's see. So you can just run this without, and it will open browser. Let's see. I mean, this one here, link. Oh, so now I can see here how many users would you like to test. I will just take 10 for that. Let's see, every 2 seconds, and you need to identify the host. Our host is localhost, and if we now click start, let's before clicking start, let me just do this to check the Docker statistic. So you can see here, this is our fast API. It's used 20% of the CPU, 125 from the let's see memory. And when I start now, it should be, let's see, jump to, I don't know, maybe 100. And you can see now, let's see, just resize this. And you can see here, this is our host. This is a status. It's running. Number of users is 10. Frame per second, rate frame per second is 31, 33. And there's no failure, let's say, in endpoints, because we are just testing only one endpoint. And now if I just go to the chart, so you can see this is the total request per second. And here, for instance, It's testing already 30 per second, and it is down, going down. Now, the most important stuff for us is number of users, which you can see here is starting with 0, 2, 2, 3, I mean, till 10. And you can see it's fixed now. It's 10 users for each request. And this is the response time for this 50%. I mean, 50% of the time it was, let's see, 300 millisecond, 400 millisecond, which is, I know it's bad, but I'm not using the GPU, and also everything is running here in my PC in notebook, which is, I will see, it's not that high performance. And 95th percent, it's let's see, more than 600 milliseconds. And here you can see it's going up and down, and it depends on the test. I mean, the number of users we have. Here we have only 10, and if your PC is, let's see, powerful PC, it will, you can see, for instance, number of users is fixed, and response time, it might be just a little bit down and up, but not like this. And you can see here it's 900 millisecond. It's almost 1 second per, let's see, per image. As I said, it's not that good, but it's uh, it's good. I see, you can see here, this is the random, the output of this printing. And yeah, let's see, the CPU is not 700%. So you can see it's jumped, and it means everything is running okay. Maybe the running time it's not perfect, and this because I think it's related to the resources of the PC that I'm using. Now, next time when we, let's say, train our model on the cloud, and we will docerize this and save it as a registry in the registry. Now we will try to run this fast API on the cloud, and try to test it from here. Let's see, using Locust, and we will see what is the performance, and we can see, let's see, we need to improve or not. And by the way, I'm using now, let's see, the fast API with only NumPy. So if I'm using now the Tosh as well, so this will increase the time too much. So that's why I like this. It's fine for me, and I mean, of course, I have no GPU, but Atlas is working with no issues, and this time here is expected. The running time is expected because the resources. And let's see. Now he, so after testing this, let's see, you can see, are certain endpoints slower than others, because here I have only one endpoint. If you see here, I have only testing one endpoint, which is predict. You can also test the other endpoints, which is, let's see, if you see it here, if you see, we have predict, health, config, model information. You can test all of these endpoints, and for this you can get a separated, let's see, graph. And what about, let's see, the time, the CPU and RAM? You can see it here from the Docker image, from this. And now, because I'm not using a powerful PC, I'm not quite sure is it fine or not. But I would say it's not fine, because the running time, it's taking too much. Let's say the latest one, it's 200 milliseconds. With CPU, I would say it's fine. I mean, 200 milliseconds. Let's see, even half a second, it might be okay. So yeah, I mean, once we have testing the Kubernetes, we will see many, let's see, graphs, and we will see the CPU, GPUs, and everything. I will test everything in the Kubernetes. And stick around. I will see you next time.